Jai Sai Ram to all. So this video is all about the ray diagrams which are formed by the spherical mirrors. So the very first point which I would like to explain you all, that when an object is placed in front of a concave mirror, the image is formed, and the image is formed when at least two reflected rays intersect. So for this, there are certain rules which I would like to explain you. So the very first rule, the rule 1 which I would like to explain you, is a ray of light which is parallel to the principal axis of a concave mirror passes through its focus after reflection from the mirror. So we all know that this PC is our principal axis. And what the rule 1 says, that if any ray of light is coming parallel to the principal axis. So let's suppose a ray of light is coming parallel to the principal axis. So this arrow indicates that the ray of light is coming and striking our concave mirror. And after striking, it will pass through the focus. So that is the very first rule. It will pass through the focus. That is our rule 1. So I repeat the rule 1 and you need to get it, that a ray of light which is parallel to the principal axis. This is our principal axis and the ray of light is coming parallel to the principal axis. On striking, after reflection, will pass through the focus. The rule number 2 states that a ray of light which is passing through the center of curvature. We know that this is our center of curvature. And if I just extend a little bit of the principal axis, and now a ray of light. So the second rule states that if a ray of light is coming from the center of curvature, we could notice that this is our center of curvature, and now a ray of light will pass through this center of curvature. It will retrace its path or will reflect it back along the same path. Now what does this mean? That suppose this is the ray of light which is passing from the center of curvature, C. So it is coming over here and striking our mirror. After striking, it will retrace its same path or reflect it back along the same path. This is our rule 2. Followed by rule 3. Now what does rule 3 states? Rule 3 states it's just the contrary of rule 1. What was our rule 1? That the ray of light is parallel to the principal axis and passing through the focus. Now the rule 3 says that a ray of light will come through the focus. After reflection, it will become parallel to the principal axis. See how we will show this. It's very simple, that the ray of light is coming and passing from the focus. After passing from the focus, it's getting what? It's getting reflected back. But how? Yes, it's coming parallel to the principal axis. See, in all the 3 cases, I have marked the arrows, and marking of arrows is very important so that it indicates which ray is coming from where, and after reflection, it is going at which direction. So these are the 3 basic rules which we will be utilizing for drawing the ray diagrams. Now I'll be teaching you the basic of how to draw the ray diagram. So the very first ray diagram which I'll be explaining you, we'll be going one by one. I'll be telling you each and everything required for drawing the ray diagram so that you are clear. So very firstly, we will be writing where is our object, where I'm keeping my object. So in this case, I am keeping my object at infinity. We'll go one by one. So my object is at infinity. This is the symbol for infinity. You can notice it. Now I'll be telling you some of the measurements. If you will opt those measurements, you will get a very clear ray diagram which will impress your examiner or invigilator as well. Okay. Now, I have drawn the line of 8 centimeter and marked some of the coordinates. So this is the line of 8 centimeter and I have marked the points with the gap of 3 centimeter. You could notice from 8 to 5, 5 to 8, 3 centimeter, 2 to 5, 3 centimeter. And I'll let you know why. See, this will be our focus this will be our pole, followed by focus and center of curvature. The distance from pole to focus must be equal. I have taken it as 3 centimeter. You can take it as 2 centimeter as well. And from focus to center of curvature as well. This is 3 centimeter. Now, we know the distance from center of curvature to pole is called as the radius of curvature. Now, I am setting my compass to the radii of 6 centimeter. That is from center of curvature to the pole. If you could observe. And from this center, I will draw a spherical mirror. That is my concave mirror. I hope this is clear to you how I have drawn my concave mirror, keeping my compass at center of curvature and taking the distance from center of curvature to pole. If you have taken the gap of 2 centimeter, then the distance from center to pole will be 4 centimeter. I have taken the gap of 3 centimeter and hence got the distance as 6 centimeter and made the mirror. So the very first thing which you need to keep in mind while drawing the ray diagram, as I told you that two rays will meet and will lead to the formation of image. And where we are keeping our first object, the object is at infinity. At infinity means I am unaware that where my object is. So in this case, I'll not keep my object on this principal axis. If I'll keep it on the principal axis, that means I know where my object is. But in the case of infinity, I am unaware from where the rays are coming. So I've just supposed it away from the principal axis. Now the very first rule which we have learned. From the top, I'm drawing a ray which is parallel to the principal axis. Yes, a ray which is parallel to the principal axis. It's coming. On striking from the mirror, it will pass through the focus. So we are passing the ray through the focus. Similarly, from the bottom itself, where we have kept the object, I am drawing another ray. The ray is coming parallel to the principal axis. It is coming parallel to the principal axis, and on striking, it will pass through the focus. See, you could yourself observe that the diagram is very neat. You can draw the shaded portion indicating that this is our concave mirror for the better understanding. So as you can see in this ray diagram, it's very clear. Why? Because I have not drawn it free-handedly. Mark my words, you cannot draw the ray diagrams with any of the measurements. It won't come exact in each and every case. You need to be very careful and take the proper measurements for drawing the ray diagram. So this is our first case. And you could see where our two rays are meeting. Our two rays are meeting at this point, focus. Yes. So now we need to write 3 characteristics of the image, which I will tell you. So always there are 3 characteristics of image. I will tell you what are those 3 characteristics so that you can always write yourself in the next sum of the ray diagrams. So the very first is where is the image formed. So you could see the rays are meeting at focus. So the image is formed at F. You can just write at F or focus as you want. I hope it's clear. Secondly, the nature of the image. The image formed is real and inverted. If the image would have been formed on the other side of the mirror, it would be virtual and erect. But since it is formed on the same side, in the case of mirror, it is real and inverted, and the rays are actually meeting. When the rays actually meet, it is the real image, and we will draw one case when the rays will appear to meet. Then it will be a virtual and erect image. So second is real and inverted at F, and third is point sized. What is it? Point size. Since we cannot see any size of the image getting formed, only a point size image is getting formed. So these are the 3 characteristics of the image. Okay, now let's move forward to another case. The very first case which we have drawn when the object is at infinity. Now we will be bringing our object beyond center of curvature. We will be moving like towards the pole one by one. So I've already explained to you how to draw the image when the object is at infinity, and I will be dealing with the ray diagrams one by one. So the second ray diagram is object is beyond C. This is a center of curvature. I have to take the object somewhere beyond C. So for my convenience, I am taking my object to be near about 2 centimeter. You can take it as per your convenience. This is my object and I have named it as A, B. We need to name the object always. So the rule goes like the very first rule which I have already taught you. That is, it is the ray coming parallel to the principal axis from the top. The ray is coming parallel to the principal axis. On striking, it is passing from the focus. So it has striked and it will pass from the focus. The arrow is coming downward. The second rule, we could either take that the ray is passing from the center of curvature and retracing its path. For my convenience, I am taking the ray is passing from the focus. As you could see, the ray is passing from the focus. It's coming, passing from the focus, and after striking from the mirror, it will become parallel to the principal axis. It is becoming parallel to the principal axis. The two rays are meeting up at this point, and I'll draw the image over here, because where the two rays meet, there we get the image. Since the rays are actually meeting, it is a real image and real and inverted. So the top will appear at the bottom. This is my A dash and this will be my B dash. This is my image and the ray diagram for beyond center of curvature. So if we have to write three characteristics of image, what it will be? First, we'll notice where it is formed. It is formed between C and F. So we will write that the image is formed between C and F. You need to write it properly between center of curvature and focus. I have written in short. Second, it is diminished. What? Diminished. We could notice the size of the image is small, or we could even measure. See, I have taken it for 2 centimeter, my object. And if you could notice, my image is coming nearly about 1.5. That is the requirement why we take the proper size for the object. So it is diminished. It is smaller in size. Diminished means smaller in size. And third, we are writing the nature, that is, it is real and inverted. So that's the case when the object is beyond center of curvature. Now we will be drawing the next ray diagram when the object is at center of curvature. We can take the object size as we want. In the last case, I've taken the object size as 2. Now I'm taking it as 1.5. Again, it's my choice. Taking the object at C and marking the object as AB. The measurements are just the same as I've taken for the first ray diagram. 3 cm between P to F and again 3 cm between F to C. The rules remain the same. The ray is coming parallel to the principal axis. On striking, will pass, yes, I hope it's learned to you by now, will pass from focus, and we need to always draw these directions properly. The second ray, again, it will pass from the focus okay. Since you could notice the image is forming at C, I have named it as A dash, B dash. The size of the image is exactly the same as the size of the object. So the three characteristics of image in this case would come like, first, where is the object at C? Image is also formed at C. So the very first characteristic is that the image is formed at C. The second characteristic would be like, yes, it's of the same size as the size of the object. And the third, it is real and inverted. Don't forget to mark the arrows as I have done in this case. It is from the focus and it is becoming parallel to the principal axis. So this is the case when object is at center of curvature, and it is one of the most important ray diagram, because in the further lectures I'll be dealing with some of the numericals which correlate how to draw the ray diagram by understanding the numerical. So this is very important ray diagram when the object is at center of curvature. So the next ray diagram, moving ahead, is when the object is between F and C. Again, I am taking my object of 2 centimeter, naming it as AB. The rule goes the same. The very first rule, yes, it is parallel to the principal axis. The ray is coming parallel to the principal axis. On striking, it will pass through the focus. The next rule goes like, it will pass from the focus, and on striking it is coming to the focus, and on striking it will go parallel to the principal axis I, and then it's reflected and goes parallel. The two rays are meeting at this point, and where my two rays will meet will give me the image. Okay, I have drawn the image where my two rays were meeting. Name the image as A dash, B dash, and you could easily recognize that the size of the image has been increased. So the 3 point goes like the very first, yes, object was between F and C, and the image is beyond center of curvature. So the image is beyond C. The second point which we need to notice is that the image is enlarged, the size has been increased. And the third point, the nature, that it is real and inverted. So this is the case when object was between F and C and we obtained an enlarged and an inverted image. Moving ahead to the next case, when our object is at focus. The measurements are just the same. The object is at focus, size 2 centimeters, named it as A and B. Okay, the very first rule, the object is coming parallel to the principal axis. As you could see, it's parallel to the principal axis. After reflection, it will pass from the focus. The arrows needs to be drawn. And the second rule goes like, the rays is passing from the center of curvature from the top. I have passed it from the top, and we know it retraces its path. So it has gone through this way. After striking up, it is coming back to this way. We could notice that these rays are parallel to one another, and even if on further producing them, they won't be formed or just meet at a single point. So in this case, our image, we do not know where it is forming, means that the image size is extremely large. तभी वो एक point पर नहीं meet कर रहे हैं. So we will be writing some of the characteristics. First, the image is formed at infinity because we are not knowing where these image or the rays will meet. Second, the image is highly enlarged. This is very important point. When the object is at focus, the image is highly enlarged because it is not getting formed. The rays are not meeting. And the third, at the last point, the image will be real and inverted. I hope that the ray diagrams are clear to you, and if yes, then please hit the like button and comment so that I keep uploading the ray diagrams or the queries for class 10 science and some other content. The next, we are coming when the object is between P and F. So I have again drawn my object between P and F, keeping the size same, that is 2 centimeter, naming the object as A and B. So if you notice, first we have drawn the case when the object was at infinity, then we came to beyond center of curvature. Third ray diagram, when we have kept the object at center of curvature, which was very important, I told you. Coming ahead between C and F, then at F, and the last ray diagram for the concave mirror when the object is between P and F. So this is also very important ray diagram because it connects to the numericals clearly. I'll show you in my next video. You can check it out from the content. How to draw the ray diagrams for the convex mirror and how to relate the ray diagrams with the numerical. The link is given in the description box. Meanwhile, the rule goes the same. It's parallel to the principal axis, and on striking, it will pass through the focus. The second rule is again the same. The ray is passing from the center of curvature, if you could notice, and it retraces its path. It's going and coming back again. Now, if you could notice, the rays are becoming parallel again. But if I'll produce the rays towards the right side or behind the mirror, there are some chances of meeting. So I am extending my principal axis to just check whether is there any scope. And since it is behind the mirror, the rays will appear to meet, but they won't actually meet. That means we need to draw the dotted lines when we are talking about here. So this is the case, or this is the place where my image is getting formed. It is behind the mirror, and it's A dash, B dash. So when the rays appear to meet and actually do not meet, we call it as virtual image. What we call it as? Virtual image. We could notice three characteristics. First, the image is formed beyond, it will be behind. The image will be formed behind the mirror. The second case will be the image is enlarged. You could notice the size has been increased. And the third, it is virtual and erect. You need to remember which is the case when the object, or when the image formed is virtual and erect. When the object is between P and F, and I'll literally say this is again very important case. So that's all for the ray diagrams for the objects. Keeping in the case of concave mirror, you can check out my certain other videos where the ray diagrams are for the lenses, the convex mirror, and we have numericals correlated with the ray diagrams. Thank you for liking the video, and if you have not subscribed my channel, kindly subscribe it. Have a good day. Jai Sai Ram.